different. Yeah. There's no less right passes. So let's look at distribution here. We've worked with this a bunch. We think back to those yellow cards we were working with on the thing yesterday. They look very, very much like this. So we can write our distribution in a couple of different ways. We can use the little box to help us do this. So I know there's a lot more than this on the page. Y'all good? We don't need to do necessarily every single one on the page. We're just going to kind of do a few of them. So we're looking at page 70. And we're going to look at kind of a smattering. We're going to start with 1 and 2 because they want us to put the area. So what is the area of this rectangle here? This one. How do we get that?
We did length times width.
Length times width. So our 4 times 5. So the area of this rectangle here is 20. What's the area of the rectangle for number 2? 7m. We don't have enough information to get any more detail than that. We just take our, again, width times length. 7 times m. So for number 5, as I say, we're going to have our 4 times the x, absolutely. So it's going to give us a 4x.
Plus 3.
Plus, what is this one? How tall is this one?
Oh, plus 4.
I was like, this one is 4 high and 3 wide.
12.
12.
Oh, yeah.
Okay, 12.
Because we multiply. So this whole piece is 4x plus 12. If you want to write this as the sum or as the product, that would be our 4 times the x from the side plus the 3. So these two statements are equivalent. They mean the same thing. That's what these are all about. These are all about these equivalent statements. One is easier if I'm trying to get rid of some multiplying. One is easier if I'm dealing with subtraction. There's times when we're going to want to have it in either way. So looking at 11, just jumping over the line things there because those are silly.
Would that be 5x plus 35?
Mm-hmm.
Or 5x plus 7, like in parentheses?
Yep. Because I definitely do not have sports announcers adding commentary on what I'm doing right now. So whoever's listening to that podcast should turn it off. So we have that our 5 times x gives us 5x, and our 5 times 7 gives us 35. So we can write this as our product, which they show us at the bottom, with our 5 times x plus 7, like they have down here. 5 times our x plus 7, or we can do it as the area as a sum, where we have this chunk added with this chunk, our 5x plus 35. Wash your face. So doing the same thing with number 12, writing it as a product and writing it as a sum, how would we write this as a product? It's very much the same kind of vibe.
X squared plus 12x.
That would be doing it as a sum, but absolutely. So I'm just giving us a divider because those two things go together. So our sum, absolutely, you guys are right. We have our x times x giving us an x squared, and our 12 times x giving us 12x. So 100%, we could write this as x squared plus our 12x. How would we put this as a product?
X parentheses x plus 12.
We're taking our side of x plus 12 times this side of x. So you can do them with the box, we can do them without the box. We've got lots of options. We can do it without the box though. How would we do 14 without a box?
Oh, just substitute in, right?
Now substitute, I want to do this and get this to be as our sum. So we're going to try to get rid of the parentheses.
Fill in? Yeah, like when I say substitute, I mean.
That's okay.
Yeah.
Talk me through it. What are we doing?
Put the 4 into the x and 7.
4 times the x, giving us a 4x. And we're going to take our 4 times the 7. What is 4 times 7?
28.
28. Not 30. So we can do this with the box, or you can do it without. We don't need to have it. What about for 16?
Negative 2x minus 8.
Minus 2x. Good catch on the signs. because then we're going to have our minus 2 times the 4, giving us a minus 8. And then from the right column, because I wanted to have this whole page on one page, because this is a lot. How about for 15? What are we going to get? Not Joseph.
Oh, okay.
Just saying, you have had lots of really wonderful ideas. I want to give someone else an option. 7x minus 21. Gorgeous. You guys are rocking it.
Brendan, right off of that.
Sometimes it just takes one person to get us started. And I'm just going to pump the brakes every now and then. I love that it changes in this group on who's being my talker. I love it. I would much rather us have too many people helping out than not enough people helping. Absolutely. You guys are doing awesome. What are we going to get for 17? One left on this page.
Can I answer this?
X squared plus 9x. Yes, you are right. Okay, I heard you. Okay. You did great. It's okay. All right. So distribution we have worked with a lot before. We've practiced with that bunches and bunches of times. Questions on it? This is distribution. We've used it a lot. So we are occasionally going to have to go backwards. Distribution that we are undistributing. Everybody's mostest favoriteest thing.
Oh.
Factoring. It's undistributing. That's all it is. So we're going to look at the next page on 71. I was going to say. You're fine. I was going to say we have things, we are working with it. I'm just giving some barriers here because it's really hard to tell which ones are going with which. I should have not done those wiggly. Those look a lot. We're just going to do this. Just because they have a lot of pieces with these and it's a little aggressive. So we have on this first one, which is technically number 2 because number 1, they pretty much did all of it for you. We have 5x plus 20 on the inside. And they've already picked for us that they're going to take a 5 out. So if we were writing this as our sum, the way we did on the previous page where we wanted our no parentheses, we knew it was 5x plus 20. But if we take a 5 out, so if we have this inside bit, no, naturally my lazy pointer froze. So if we have this inside bit, and we're going to take a 5 out, what is going to be left up here if I divide by 5? X. Because if I had an x up here and I had x times 5, that would give me 5x. So it's undistributing is what factoring is. So on the top up here, I'm going to have an x. What's going to go here?
4.
A 4. Because 20 divided by 5 gives us a 4. So if we wanted to write this as a product, I could have this as my side of 5.
That 5x plus 4.
And the top is our x plus 4. Because when they're on that same side, we add them together. And knock that same exact piece of paper off.
Oh my god. That's how we do it.
So then let's look at number 3.
Oh yeah, that's
Yeah.
x and 6, yeah.
Yeah, we're going to have a 6 over here and an x up here. Because 6 times 8 gives us 48. So we know this is going to be a 6 because that's the only thing that will multiply by 8 to get a 48. And then if I take a 6 out, that's going to leave me with an x here. So we can write this as 6 times our x plus 8, or we can do our 6x plus 48. So then we get into stuff like number 5. Number 4 is very similar. You guys can do number 4. I have total faith in it. Number 5, we don't get as much information. I mean, we get some, but not as much. So we're told to take 5x plus 35. And they do tell us what to take out to start with, just to kind of help us get into it.
Let me be, so you have an x on the top left.
Mm-hmm.
Far off.
So I'm going to fill it in a slightly different order than you're giving me.
Okay.
Because I'm going to put my 5x plus 35 inside the boxes first. I know. Sorry, I'm writing on the wrong one. I know they want us to factor out 5x and 35. Like, those are the pieces they give us. A lot of times they won't tell us this number up here in front. We just have to figure out what both of these have in common. So they gave us a clue here because they told us that 5. But that's going to be the piece we have to figure out for the next ones. So if I take a 5 out on the front, what's left up top?
7. Oh, shoot, X.
An x right here. And what's left up here?
7.
7. Because 7 times 5 gives us 35. So I need x times 5 to get this 5x, and I need 7 times 5 to get 35. So 5x plus 35 is 100% the exact same thing as if we had 5 times the group that has x plus 7. So 5 times x plus 7 as a quantity is the exact same thing as 5x plus 35. They are equivalent. They mean the same thing. So now when we start looking at the bottom half of the page where we're looking at 8, 9, 10, and on, they don't give us any of the pieces for when we're solving. So we have to purely factor by ourselves. So you can do them with the box, like we have here, or you can do it without. So I'm going to do 8 with the box, and I'll do 11 and 13 without, just so we see it. So when we have something like 8, we are told 7x minus 21 is what we're looking at here. That's without parentheses. So if it's without parentheses, that's our inside. 7x minus 21. What number do 7x and 21 have in common? What do they have as a factor in common?
-3.
Can I divide 7 by 3 and have it be not a decimal? Yeah, I was gonna say, but I can divide 7 by 7. I can divide 21 by 7. So both of them are divisible by 7, or divisible. If I divide them both by 7, then what am I going to be left with on the top?
X.
An x right here, and a -3 right here. So as a sum, we have our 7x minus 21, or we can do 7 and x minus 3. They're equivalent. So 7, that number out in front over here, and our x minus 3. We always want to try and take the biggest number that they have in common. So let's look at 11 and 13. And then we'll talk briefly about 72, and then we'll be done.
Factor.
So if we look at 11, which I've got it way over here, it's way down at the bottom. Just because you guys can do it with the boxes. We've seen those. If we just look at this, 4x minus 16, what do they have in common? What number can I divide both 4x and 16 by? 4.
Yeah.
I could divide by 2, it's just not the biggest. We want to always take out the biggest piece we can.
X minus 4.
So if I take a 4 out, what is left if I take 4 out of 4x?
X minus, X.
Just an x. And what is left if I divide 4 out of 16?
-4.
So the minus sign stays the same. 16 divided by 4 is going to leave us with a 4. So we can factor it just like that. If you are not sure if you've done it right, easy peasy test, redistribute it. If I take my 4 times my x, where's your face board? If I take my 4 times my x, I get 4x. If I take 4 times minus 4, I get minus 16. It's exactly what we had. So if you're not confident in it, redistribute it and make sure that that gives us what we need. What about for number 13?
9.
We've got 9x and minus 81. So what number is 9 and 81 divisible by? 9. I mean, technically they're both divisible by 3 as well. It would just leave me with more pieces that I could factor out. So if I take 9 out, it's going to leave us with x minus what? 81 divided by 9 gives us another 9. And again, if we're not confident in that, which I get it, redistribute it. Multiply our 9 times the x and then multiply 9 times the minus 9. We should get exactly what we started with. These pieces are equivalent. They mean the same thing. I can draw a picture and this makes sense. Minus 7x minus 21, x minus 3 and 7. These all make sense and they work together. I'm not saying they make sense because sometimes the box is weird. But they are equivalent and they mean the same thing. So the last piece that they want us to look at with our distribution, 72, last page, promise, is deciding if these are equivalent or not. Did they distribute properly or did they factor properly? Some of these are going to be yeses, some of these are going to be no. You do not have to use the little frame off to the side. Like, this is available if you want to use it, and I'll show you how we can here on the first one. But take a look at number 1. What do we think? Are these equivalent or are they not equivalent? My 3 parentheses x plus 3 and 3x plus 6. What do we think? Is this
No.
equivalent to this? Why not? I was going to say, think about if we were to distribute this one out. 3 times x would give us 3x. And 3 times 3 gives us 9. So 3x plus 9, it's not the same thing as 3x plus 6. The way you can see that over here is it's kind of intending this to be like a half a box where we take our 3 and our side that had x plus 3. That's what it's viewing this side as like a little baby box. It's weird. You don't have to use this thing. They're just giving it to you as an option. It's like a weird little baby box that they've kind of half put walls on. It's weird. If you, hello chunky pen. Okay, we'll just try that for a second. If you want to do the box, it's totally valid. We can look at this and say, hey, this would give me 3x. Awesome sauce. 3 times 3 gives me 9, not 6. So you don't have to use this little frame thing, but some of us are very used to the frames, and so they're there if we want them. What do you think about number 2? Are these equivalent or are they not equivalent?
They are.
They are?
Yeah.
Okay. I'm with you. Again, we could either distribute this to get 6y plus 6 times 1, which is 6. Or you could look at this thing and say, hey, they're both divisible by 6, and I could factor a 6 out, and that'll leave us with y plus 1. Either way we go, they lead back to each other. They are equivalent. They mean the same thing. So yes, these are equivalent. I'll go back and just officially say, no, they're not equivalent. Let's look at 3. And that'll be the last one that we do. Because I want to pass it down. What do we think? Are these two statements, x times x plus 4 and x squared plus 4, are they equivalent? I see several shaking of the heads. Please, Give me 1 second. Why not? Yeah. When I distribute this, I'm going to have my x times x, which is going to give me x squared. Love that. Perfection. X times x is x squared. If I take x times 4, I get 4x. They dropped the x over here. This is entirely different. If I was to draw this one in a box here, we'd have our x and our x plus 4. and it would look like this. X squared plus 4 are two entirely separate squares. This would be an x by an x. I could do this as 1 by 2 or 2 by 2, but they're not attached to each other. They're not exactly the same. I just have two things in addition to my x. So just be careful when we're thinking through things and make sure if we're distributing, we're being careful. If we are factoring, we are being intentional and careful. Okay?
They're not equivalent, right?
Say it again?
They're not equivalent.
These two are not equivalent.
Okay.
That's not a pen. Nope. There we go. Easy to see. These ones are not equivalent. What do you guys think about 4? I don't have it up here, but you guys have it on your page.
Yeah. Equivalent.
Yeah. Even if it has more than one letter, we can still do that. Y times x gives me yx or xy. Totally fine. I can switch them. Just like y times 2 gives me 2y. 4 is equivalent. So we had no yes, no yes. So make sure we're paying attention for these equivalents, whether they are, whether they aren't, all that jazz. Okay? So what I'm going to pass out now, since we're having a test on paper, I have review on paper. Okay? So if we ever have a test on paper, I give you a review on paper so we can practice it. This has practice questions for every type of question on the test. Not guaranteeing that every question on here will have a representative on the test, but if it's on the test, it's covered on here. So tomorrow, we're going to work through another one of these pattern things, because you'll see a couple of those pattern problems in here. We'll work through another pattern activity tomorrow and use that to talk about the rubric, because any of the questions on the semester final that have the short answer, where you have to like do any math work, get graded on the rubric. So we have at least some questions on every test graded on that same rubric, so that we can kind of practice and see what it's like. The rubric is not super duper intense. Honestly, it gives more points for partial answers than a lot of teachers do. And we'll practice with that tomorrow just so we can see it. But we're also going to use that to look at some of the patterns. So this is review for the test. There's another one of those patterns down here. There's at least one pattern inside. A lot of them are built like some of the activities we've done, whether it's finding our equivalent expressions. Oh, look, here's our factoring stuff that we were just talking about. Whether or not things are equivalent, that kind of stuff. Number 1 is order of operations things, PEMDAS. So it's all based on things that we have done. Again, if you need copies of notes or anything that we missed, like number 5, think about our the cell phone stuff where we did with the big P cell phone and the little P cell phone. Those kinds of things. Okay? So a lot of these you guys can do, I think.
So for the first, for 1A and 1C,
Mm-hmm.
you just like, it says just simplify, so don't
Yep.
solve them.
I was gonna say, we don't have an equal sign, so we're just gonna simplify as much as you can, but it's order of operations stuff.
Okay.
So what are we gonna simplify first?
The right, the -7, the 3, and -1.
Mm-hmm. Yeah, we need to, because we need to deal with what's inside those parentheses first.
15 plus 2 minus 21 plus 7.
3 minus 21. Simplify inside the parentheses first, make your life easier. What's 3 minus 1?
-21.
What's 3 minus 1?
2.
Make your life easier.
Okay,
Yeah. As I say, you can get there. Yeah, if you found the sign thing, it works. You should still get the same answer the same way. Yeah. Yeah. The minus 21 plus 7 will still get you down to that same spot, but don't let me go super crazy.